I have. So we will discuss buckling failure using ANSYS Workbench software, right? So this is the question. Buckling failure. A dog bone shaped specimen is examined for static, fatigue and buckling failure. The specimen is made up of structural steel with geometric L-shaped. Okay. So what is that means? We are going to find the solution of dog bone shaped. So first we are going to find the static structure. After finding the static analysis, we are going to find the fatigue analysis. Then finally we are going to find the buckling failure also. So by using the structural steel. So the shape, the geometric shape is look like a dog bone shape. So here what we are going to means in the bottom of the shape we are going to fix and the top we are going to apply load. That load is 50 megapascal. Right. After applying load, we are going to check. The first one is static structural analysis, and second one is fatigue analysis. Third one is buckling failure analysis. These three things, right? So we'll move for the ANSYS Workbench software. So this is your figure actually, right? So it's a dog bone shaped structure. The dimension is given in mm. So we have the dimension. The total length of your structure is 38 mm and width is 15 mm. And we have that fillet radius, that is 3 mm. In between, that is 5 mm. So this corner is 8 mm. So first we are going to design this diagram and extrude. Extrude is 0.75 mm only. After making that extrude, the bottom corner we are going to fix this. We are going to make a fixed support. In the top corner we are going to apply the load. How much load means? It's a 50 megapascal load. Once we apply the load means what will happen means, see that it's a bone structure now. Once we apply the load means what will happen means, in between some little bit crack will be take place. That before the crack, how much the buckling will be take place. That only we are going to calculate. Either after applying the load, either it will be cracked or buckling failure or it is tape. That only we are going to analyze by use of your ANSYS Workbench software. Right? So we have that manual. By using the manual, step by step I will explain you. So this is the figure. First step, start your ANSYS Workbench. Next step, create the static structural analysis. See, first step, start your workbench analysis. From here, step, start your static structural. Click and drag. Otherwise, you can make double click also. Once it open means, see the first of all initially the engineering drawing we have tick mark only. Why? Because initially in ANSYS Workbench we have the material, default material as a structural steel only. So our problem also we are going to use structural steel only. So no need to change of your material. Next directly we can move for geometry. So right click and new geometry. Otherwise you can make double click also. So once you click the geometry means, new geometry means, automatically we have another window is going to be open. That is starting designer models. We have the second window. The second window going to be open. Okay. After opening that, what we are going to means, we are going to create the structure like this, which we have the geometry. We already have the geometry. So this is the geometry we having, the length, width and all the size which I have discussed. So the unit is in mm, right? So once the design modeler, once the geometry is open means, first of all initially we are going to draw which angle we are going to draw means, select that XY plane and create that lookout face. So from here, before starting the diagram, check the units. So our diagram we are going to draw in millimeter only. So initially it will be checked in meter. So change into millimeter, right? After making millimeter, we are going to start the sketch. For before starting the sketch, you have the dimension. For easiest way of drawing means, you can use the grid option. See that we have the grid. Select this grid option. Switch on the 2D option and the snap option. See that major grid size. It's a graph only. So the unit is in 10 mm. The unit is in 10 mm major grid, and the minor grid also is 5 mm. You can change it. Both 10 means you are not having confusion. See that the unit is 10 mm. Now I am changing both unit also 10 mm. See here only. So from here the unit scale is 1 mm, 2 mm, 3 mm. So 10 mm and 20 mm. Like this I am going to be created. So if you use this grid option means we can easily draw the diagram. So I am going to go for the drawing option line. So you know the shape. It's a dog bone shaped. So for this we have used the polyline option. See, click that polyline option from here. So what is the top length width we having 15 mm, right? So 15 mm means we can create approximately 7.5. So I'll be creating from here. Understand? Why I'm creating from here means see that is 10 mm, 20 mm. So what about your total length is 38 mm now. So for approximately 38 divided by 2 means 19. So I can create from here. Understand? I can create from here like this. Here I am going to stop. Next, what about that this line? This is 8 mm, right? So I can create up to here. Next, in between we have 5 mm. So 2.5 means I can stop here. Like this, I am going to bottom. You can stop up to the first line here. Next, up to here. Next, 19 mm. Here. Here 2 mm, this one, and finally right click and close them. See that the structure is created. Next you can switch off your grid. You can switch off your grid option. See that the dimension which is easily created. Now you are going to give the dimensions. So before dimensions, we will check we can give the constraint option. See that, go to the constraint option, symmetry, use the symmetric option, First of all, use the symmetric option. Why we are using the symmetric option means the origin point from top to bottom or left to right, it be going to be kept in the center of this. For that purpose, we can use this symmetric option. So the first one is from this center axis, this both going to be symmetric, right? Like this I am going to create. Next, again click the symmetry option. For this center, this line, I am going to create these both are symmetry. See that, these both are symmetry. That's all, completed. Now you can give the dimension. See that, go to the dimension. The first dimension, we can give the vertical dimension. What is the vertical dimension means? From here to here. From here to here, how much the length? 38. It's almost the same 38 only. For that purpose only, I am using your graph option, right? Next, we can go for your horizontal. See that, for horizontal dimension means from here to here. See that, it's 4 mm only is there, but in our diagram we need 5. So change into 5. Understand? Next one is the top one. For the top one, click the general one. From here to here, how much is the length? Initially it's in 16 mm. So change to 15 mm. Understand? Like this. Next, one more important thing, this dimension, general, from here to here, right? This dimension is 8 mm. Okay, approximately everything correct. Now we want to check all the dimension is correct or not. So we can check here also. How much is that? This is 16 is that, change to 15. Next, this one is same only, no need to worry about that. What about this dimension? Check it. 10, 8 only, and this also 8 only. So almost everything is 8 only. Everything is completed. Now what we need means we need to create a fillet option. Go to modify. Here we have the fillet. Click that fillet. So the radius is 2.5 mm is there. Change to 3 mm. As per our question, we need 3 mm only. See the geometry. Here the radius is 3 mm only. So change to 3 mm. From where to where we want to create means click this one and this one. Like this. All the four corners we want to create your fillet option. So here almost your geometry is completed. After completed, click the generate option. Click generate. Now your geometry is completed. After then what they are asking means you want to create a extrude option. How much the thickness is given means 0.5 75 mm thickness. Go to extrude option. Which sketch you want to select means see that XY plane, we have the sketch 1. Select the sketch 1. From the geometry, click that apply option. So in the geometry, the sketch 1 is selected. Next, they are asking, see that you can change here like this. See the extrude is showing, that is 30 mm is showing. How much we need means 0.75 mm. Click. Then generate. See that almost your geometry is completed. This is your geometry. It's a dog bone structure. Right? Next, see here we have the two windows. We have two windows. So the geometry which is completed means directly you can close the window. If you close the window means see that in the first window and this window you can see means initially the engineering drawing we have the tick mark. Now the geometry also we have the tick mark. Next what we want to means go for the model. Next one is we have that model. See that. Click that model option. Now again one more window is going to be open. See that up to the drawing is completed. Next the extrude option is completed. Next directly we can go for the model. See that model is opening. It takes some time. Okay, right. So we get the structure like this. So first initially you check the geometry. See the geometry, we have the solid option. The solid assignment, the material is structural steel only. Why? Because it's default storing the anti-swerve. Next what we're going to means we're going for the meshing option. So in that meshing option, before giving the meshing option, here also you want to check the unit. See that the unit is metric kg per ns. Okay, right. The metric is not changing. So no need to worry about that. Next you want to give the sizing. The element size I'm going to give 0.5 mm. See that 0.5 mm. From that mesh you can right click and generate mesh. Otherwise in the top also we have that update mesh. You can click here also. Right? See that generate mesh. The mesh is generated. You can see clearly. See that the mesh is clearly completed. Right? Next what we are going to do is we are going to give that what is the first initially our question is clearly given. What is the question is given? So first we want to find the static analysis. Next we want to find the fatigue analysis. Next finally we want to find the buckling failure. So first initially I will check the static analysis. So for this static analysis, what is your boundary condition is there means in the bottom surface we are going to go for the fixed support. In the top surface we are going to apply the pressure load above 50 megapascal. Right? So from the static structural, right click, insert fixed support. See that here fixed support is there. So anyone side. So here I am going to fix it. So now this is the bottom. I am going to click here and apply. If apply means see that fixed support is created. Next in the opposite direction, that is the top surface. So I am going to give the pressure. How much pressure I am going to give means 50 megapascal. See there. They are asking the magnitude. So which direction you want to give means see that towards the y direction. Towards the y direction means upward. So you want to give the compression load. Compression load means you can give minus 50 megapascal. How we going to give means here. Left side we have the defined by here. First before that applying load, that we want to apply that load means in the top surface. See, click the top surface and apply. Geometry is selected now. Next they are asking defined by normal tool. You want to change into components. So from that here they are asking which component. So in the y component only we want to give that load. From that y component give minus 50 megapascal. Right? After giving minus 50 megapascal, see that the image is created. You can able to see the arrow in the top side. See that the arrow in the top side you can see the arrow. It look like in the bottom side. Bottom side means we are giving the compression load. We are giving compression load. So up to here we are completed. Next what we are going to find means the first static deformation. We want to find the deformation. See that deformation, total deformation. Next you want to find the stress tool, maximum equivalent stress. Next we can find the equivalent stress. Click the equivalent stress, right? After that, just right click solve. 0.5 mm to apply boundary condition we applied. Next after applying load, the first one is total deformation. Next we are finding the equivalent stress. Next we are finding the stress tool also. They are asking need to find the maximum equivalent stress. Stress tool here, see that stress tool, the safety factor. If you click the safety factor means see that 0.76 is there. So what will happen means the static pressure. If you apply load 50 megapascal means we are getting that safety factor is 0.76. What is by 0.7 means the factor of safety FOS is greater than 1 means your static pressure is failure. So now the value is less than 1 only. So your static pressure is not failure condition, right? So you can see your total deformation value. You can able to see your total deformation. What is the maximum total deformation is 0.094, right? Next you can safety, factor of safety is safe, equivalent stress also. Next what they are asking means you want to find the fatigue, right? So again click the solution, right click, insert, see that in the bottom we have the fatigue tool, click that fatigue tool. So here in the fatigue tool, they are asking in the question, what is the given in the question means in the fatigue they are asking assume the specimen of design life, the life is 10 power 6 cycles. So initially in your diagram you see means see that before that you can change that mean stress theory. See that here the mean stress theory change to Goodman's theory, right? Goodman theory. So here one cycle is given only, so directly. So this is your Goodman theory. You can able to see the graph, right? Fatigue. In the fatigue tool theory, Goodman theory you want to create. Next, von Mises only. They are having the von Mises stress calculation only directly. So you can next in the fatigue tool you want to insert life. See that right click, insert life. So in that life next right click on the fatigue tool, insert safety factor also. You want to create the safety factor also. See that right click and insert safety factor. In that safety factor, see the design life is asking. So what is the design life we are having? 10 power 6 only. So initially in your answer bench it's 10 power 9 is there. So 10 power 6 is there means 10 e power 5. You can click 10 e power 5 means 10 power 6 will be creating. So in that particular tool, right click, evaluate all research. So now you can able to see your fatigue. See that how much fatigue takes place. Right, like this. The bend will be taking place like this. So what is the factor of safety? The factor of safety is 0.226 only. Right. So in the fatigues also our design is safe only. So first initially what we are checked? We are checked that static analysis. In the static analysis, factor of safety. See that the factor of safety is 0.76 is safety. Next one is the second we are checking the fatigue tool. In the fatigue tools also the factor of safety is 0.26 is less than 1. So the fatigue also is safe. Next what we are going to means we are going to find the buckling analysis, right? So buckling analysis means the top we are applying the compression. So in between the center only the buckling is take place. So we'll see whether the geometry is safe or not. Whether the geometry is safe or not. Like the same geometry only we are going to check. So once you completed this one means here we can't able to check the buckling failure. Why? Because this is static structural analysis. Just to close this window, but we are going to use the same diagram, same figure only. For this same figure we are going to check the buckling analysis. So like this, see that in the left side analysis system, here we having that linear buckling. So click that linear buckling, the engineer drawing, geometry, model, setup, solution, everything is same only. So click like this. So you can see the joining, see the engineer drawing are same, diagram we are getting, geometry also same geometry, model also same, everything we are getting. But the result only we have that question mark. So why? Because means that we are creating buckling analysis. So now directly we can change the result from here. How the buckling analysis take place. So double click on the result, your design model, your model analysis will be open. So this is your model analysis. So before that, which already we have completed that static structural, fatigue tools, everything we have completed. Now they are asking buckling analysis. So in the buckling analysis, what we are going to give means we'll check first, see the question how much they are asking. Initially for the buckling we can check more than 20 types of buckling failure we can check. But in the question they are asking first 3 buckling mode is enough. So first 3 buckling mode shape is enough. So what is the mode shape means? Example, the buckling will take place x-axis, next y-axis or z-axis, x-y-axis. Like that we have different shapes we are going to be created. Sometimes it will be creating the top face only, otherwise it will be creating the bottom shape, otherwise it will be creating the center shape. Like that we can create more than 20 mode analysis. But in our question they are asking only 3 analysis only. So go to that analysis setting. Here they are asking maximum mode is that. Change into 3 modes, right? 3 modes. So in that answer is right click, insert deformation, total deformation. Up to here which we have completed, life, factor of safety, everything we have completed. Now linear buckling analysis. So this is the linear buckling analysis. So details of analysis setting, set the maximum of find 3 nodes, which we kept 3 nodes, right? Next insert 3 total deformations. So we are going to be insert 3 total deformations. Solution, insert, why it's not creating analysis setting. Okay, again we'll create the 3 model analysis. Linear buckling. Okay, analysis, just click and solve that analysis. Now it will be solving. See that. So take some time for solving. Right. So here the analysis setting we having the mode shape we having 3, right? So see here 1, 2, 3 is there. So right click here, select all, and again create mode shape result. Create mode shape result. Now you can able to see your mode shape result. See that. So 0.14, the first mode shape we are getting that 0.14. You can click play. See that. The mode shape will be creating like this. Next your second deformation. Again, right click, evaluate all results. So you can create that result, means you can able to see these three results. See that the second deformation. So this is your first deformation. So this is the second shape. See that this is the second shape, and this one is your third shape. Got it? Okay. Thank you.